Hello everyone, welcome back to the new chapter of the AI classroom. So let's recap whatever we have learned so far about the ragas. So because this is the third chapter of the ragas. In the first chapter of the video, we have learned what is ragas. It's basically the I have created a complete RAG pipeline where the robot is able to generate the response through the RAG under the not with the live data using the MCP servers or using the um, chroma db. And also there is a third category where we have the static, and we are not making any call to chroma db or the live server. It's just like reading directly from the model. So in the first video I have what is ragas? That is something. So ragas is basically stand for rag assessment. So how to assessment? Assessment is like basically if the rag can also generate the data which can be hallucinated response. So to validate that under the ragas there are multiple metrics, and one of the metrics is the faithfulness. So in the first video I have created the faithfulness file just to show how it works. So it basically it takes the answer, extract it, verify it, and then calculate the faithfulness. Now the important thing, who is going to extract the answers? That is the judge model. And who is the judge model is basically the cloud which we are using. Then who is going to verify? The judge model, which is again the cloud. And then the faithfulness will be calculated based on the number of supported claims divided by the total number of claims. So supported claims is like if there are 8 claims, and out of 8 claims if there are 4 claims are saying yes and the 4 claims are saying no, so the number of yes claims is going to be the supported claim. So 4 divided by 8, that's how it is going to calculate the faithfulness. So that's one of the metrics which is going to be which we use under the ragas. The another, and so that was the first video which we which I have created. The another, in the second video I have shown how exactly industry is using ragas. So that's let me open that file. So uh, how industry is using is basically they are using the libraries, and there in when we use the ragas library there are multiple metrics other than faithfulness. There are three other metrics like answer relevancy, context recall, and the context precision. Answer relevancy is kind of, it's basically the judge model creates three questions and embed it, cosine the distance and get the average of that, and that's how it validates the relevancy. Context recall and context precision require the data set curated by the people which can have the ground truth, and that's how it validate against the ground truth. So check the previous videos, I have discussed that in detail how exactly the ground truth is added into the data set and how can we run it. Just to recap it, faithfulness and answer relevancy can be run on the live data, while the context recall and context precision requires data set curated by the people, so it cannot be run with the live data. It can only be run in the nightly build or once or twice. So today we are going to run the faithfulness and answer relevancy with the live data. So for that I have created 4 files. Let me open that. Pipeline text underscore t1. So that's one of the file. So pipeline text t1 file is basically the actual pipeline where I'm going to ask the question to the robot and it will give the answers. And also if the category is, because I'm using the digital word classifier, it will also add the category at the context. So if the category is static, that means it is not going to the RAG pipeline. Model itself is giving the answer, that means the context will be empty. While other than that it will set the context, whatever the it is getting the context from knowledge base or chroma db or from the live server. And at the end of this file I am going to put everything into a log file, log.json file, and that file will be read by the another file called scorer. That scorer is basically reading polling that log file after every 5 seconds, g- uh, run the faithful calculation on those answers and give the score. Once the score is calculated, it will dump into into a score.log file, and that score.log file will be read by the T1 dashboard file, and that will respond. And another tab is basically where you can see the because the rack can also make the MCP call, so I'm started the MCP server. So let's start uh, pipeline. Okay, so let's say I ask a simple question: what is gravity? And let meanwhile start the scorer and the dashboard. So as you can see, it's a static, so that means the pipeline does not go through the rag, the knowledge base or the MCP. It can, the model directly can give the answer of this question. So as you can see here, it is refreshing the dashboard after every 5 seconds. The robot started giving the answer like gravity is like a big hug. And as you can see in the T1 scorer, we can see the scoring is coming. The faithfulness is none. The relevance is 0.822. Why the faithfulness is none? Because the context is empty. And why it is empty? Because it is not a rag. It's a directly we are reading from the pipeline, reading from the model. So there is no need of calculating the faithfulness for this. Okay, so let's complete that. And as you can see, the dashboard is updating every, because it is polling after every 5 seconds. Okay, let me see if I can stop this and give the another question. Okay, kind of stuck. Okay, let me rerun it. Okay, the next question I can ask: uh, who reached the FIFA World Cup final? So as you can see, it is a live data and it is fetching the MCP. So as you can see in the bottom, there is a, it make the API call. So it's going to pick up the data from the MCP and it will be updated into the T1 scorer. Okay, okay, yeah. So as you can see, the robot give the answer. The answer is still up to you since there are no current. As you can see, it's not the right answer. It's hallucinating. We can see what's the faithfulness is going to be for this one. Where in the scorer, the who reached the FIFA World Cup semi-final. Okay, so the relevance is 0.895 and the faithfulness is 0.5. The answer is still up to you since there are no current FIFA World Cup headlines. We can't tell you which team made it to the semi-final. Let's see if they will be back next. So as you can see, the faithfulness is 0.5. The next question is, let me ask another question: how many cities are hosting FIFA World Cup? Okay, so as you can see, the answer is There is no information about the Kansas City Spirit landing a FIFA World Cup. Now let's see what the faithfulness is going to be for this one. And as far as watch, you can check the website image. As it mentioned the Kansas City Spirit, so which is the, so the answer is 0.25 and relevancy is 0.7 and 0.5. Why it is 0.025? Because it mentioned Kansas City. Ideally the answer should be 16 or 20, but because it gives the Kansas City, so one of the chunk is at least contains some of the answer. And the next question, what is the weather like today? So again it is like, so it's a chilly night in Columbus, Ohio. The temperature is cool, 67. So also quite breezy, just one pay. So let's see how it's going to be. So as you can see on the dashboard, we can see for the static, because there is no context, so it's empty. But for the other question, we can see uh, the faithfulness and the answer relevancy. Now what is the weather like today? Faithfulness is 0.75, which is perfect, because it's a good, it's that is the right weather today in Columbus, Ohio. So that's how we can calculate the faithfulness and the answer relevancies with the live data. As you can see, I'm asking the questions, and on the second screen we can see the faithfulness and the relevancy. But now we have the evaluation, and every answer is code, and we have flagged the hallucination. But there is a problem, still there is a problem. Like, the truth is already given. So let's say if my kids are actually looking the answers, and the answer has the faithfulness, which is coming after like 5 seconds or 10 seconds, but they already hear the answers, and they already got the answer. They have no idea whether it was hallucinated or not. So how to control that before it is coming to, you know to control that it should not give that hallucinated answer? So that is something we are going to check in the next video, like, how to how to stop the bad answer before it's spoken, and in milliseconds. So that is something we are going to check in the next video. Till then, thank you.